always generated even if the input data are unreasonable. So your ANN will never tell that it is wrong. Okay, see for example, if you take a Google map, if you are going to follow the Google map and if you are not going to exactly follow it, your Google map will never fight with you. It will again reroute it and it will be able to give you another one result. Like that, all your Google map, everything works on ANN principle. Okay, even if the input data is unreasonable, you will be able to generate the results. Okay, that is a disadvantage. Sometimes we may enter into some unknown path in the Google map and we get lost. Okay, that is also possible. Okay, so they are not scalable. That is, once an ANN is trained to do certain tasks, it is difficult to extend to other tasks without retaining the neural network. So it is not scalable. Okay, these are some of the disadvantages of a artificial neural network. So now, how this ANN can be used in power system? Okay, so the problem in generation, transmission, distribution of electricity can be fed to the ANN so that suitable solution can be obtained. Okay, so I'll be able to synchronize all these three things in a power system. Okay, so given the condition of a practical transmission distribution system, the exact values of parameters can be determined. The parameters may be a voltage value, okay, or a transformer tap setting. Okay, then frequency, everything can be properly set by this. For example, the value of inductance, capacitance, resistance in a transmission can be numerically calculated by an ANN, making it factors so that your environmental factors, unbalancing conditions, everything can be sorted out. Okay, so in this way, skin effect and proximity effect can also be reduced to a certain effect. Okay, so these are all some of the ways of applying your ANN in your power system. Okay. Next we'll see about the fuzzy logic. So fuzzy logic or fuzzy systems are logical systems for standardization and formalization of the approximate reasoning. Okay, so it is similar to a human decision making system with the ability to produce exact accurate solution from certain or even approximate information. So what here we do is that when the time changes from 11:59 to 12, okay, when will you say it's going to be a next new day? Okay, so that is going to be when it is going to be 11:59.1 second, as going to be 11:59.2 seconds, 11:59.3 seconds. So there is a little bit of confusion state. Or also I can take this 11:51.01 second. So whenever there is going to be a confusion state, then I can apply this fuzzy logic algorithm. Okay, now we will be able to give a crisp data. Okay, so we will be able to have an accurate solution from certain or even approximate information and data. Okay, so fuzzy logic is the way with which human brains work, and we use this technology in machines so that they perform somewhat like humans. So all your washing machines that is coming nowadays as an automatic washing machine, they are going to have fuzzy logic inside. They will be programmed with fuzzy logic. So it will be able to turn on the heater and set the temperature 60 degrees centigrade. You will be able to set the dryer at say 1000 RPM, 1500 RPM, depending on setting whatever you are going to get. So once you are going to turn it on, they are going to program it by changing the nozzle. Then everything will automatically run. That is done by your fuzzy logic. So fuzzification provides superior expressive power. The one problem with fuzzy logic is that it is not adaptable. You will be able to learn. Once I program it, I can use it only for that program. Okay, it is not like your ANN, where your ANN will be able to rectify it, because I had one thing called as back propagation or feedback error, which uses experience to learn. But in fuzzy logic, it is not there. Okay, so how fuzzy logic can be used for power system? So it is used for designing the physical components of the power system. Okay, so physical components means I can use a circuit breaker, when to make the circuit breaker to be turned on. All these are crisp data. Okay, so that for that we can use a circuit breaker. That can be used in anything from small circuits to large mainframes, and they can be used to increase the efficiency of components used in the power system. I'll be using some capacitor banks. Okay, so when to turn on the capacitor banks, everything can be controlled by your fuzzy logic. Okay, it can be controlled by the fuzzy logic. Okay, so most of the data in the power system analysis are approximate values and assumptions. Fuzzy logic can be of great use because we use fuzzy rules. So once I'm going to apply fuzzy rules, the ambiguity can be removed off. Once this is within this rule, then it is going to fire. Or if it doesn't come to this rule, then the output will be equal to 0. So like this, I'll be having a very good ambiguity-free output through a fuzzy logic. Next one is expert system. So an expert system appends the knowledge of human expert in a narrow specified domain into a machine implementable form. Okay, this expert system is one of the earliest form of your artificial neural network. The earliest form of your artificial neural network. Okay, so expert system or computer program. These are all computer programs which have proficiency and competency in particular field. Okay, so here programs are being written. Programs are written to control a process. Okay, so advantage, they are permanent and consistent and easily documented. Since I am going to write the program, so they are going to be consistent and easily documented. But the one disadvantage is that they are unable to learn or adapt to the new problems. Okay, so adaptability is the only adaptability is a feature that is available only in ANN. It is not available in your fuzzy logic or in your expert system. Maybe I can use a artificial intelligence along with the fuzzy logic controller to make a artificial neural control fuzzy logic controller. That will be adaptable in nature. But as such, fuzzy logic or your expert system is not adaptable. Okay, so here I have a knowledge base. So this database is fixed. This database is fixed. So from this knowledge base, there is an inference engine which will be communicating in both the ways. And here I will be having data acquisition. Then I will be able to take a decision and explanations. Okay. So this is the basic operating principle of your fuzzy logic. Yes, our expert system. So the expert system or programs process of writing codes for this program is simpler than actually calculating and estimating value parameters using generation, transmission, distribution. So here we are writing codes. We are writing codes. Maybe it may be Fortran code or maybe C++ code, etc. to do that operation. Okay. So any modification, even a design, can be easily done. So once I am well versed with writing codes, then if there is going to be any problem, then I can go to the corresponding program line, then I can change it, then it will be doing it. Okay, the expected outcome will be present. Okay, so estimation of these values can be done, and further research for increasing efficiency can also be performed through a expert system. Okay. So now we will see a practical application. So here I have transmission line. So this is the sending end side, this is the receiving end side. So transmission transmits electrical power from one end to the other power. So here I have the sending end power, here I have the receiving end power. So this transmission line is exposed to the nature. Okay, it may be going through a forest, or it may be going through a barren land, it may be crossing a river, or may be crossing a plain, whatever it is. And this transmission lines will be very large in length. It may be 100 kilometers to, you can say 300 to 400 kilometers length. Okay, so this is exposed to the raw nature. Okay, so it may have fault occurrence. Okay, so we will be having sensors. So in this transmission line, there is a fault detector. Okay, this fault detector is going to detect the fault that is going to happen, and at what place the fault has occurred, that we will not be able to know. But when I have a fuzzification, so data from this will be able to fuzzify. So our fuzzification generally is using Takagi-Sugiyama model, TS model. This is available in your MATLAB, where we'll be using rule-based methods. Okay, we have trapezoidal rule, we have a triangular rule-based methods like this. So that can be used for fuzzification, and that input will be given to the fuzzy system. And here I have the fuzzy rules applied. So once the fuzzy rules are applied, the fuzzy system will be able to produce the output, and this output will be in fuzzified form, which will not be understandable by the machine. So it has to be again defuzzified, and then it is fed to the transmission line. Okay, so that the fault can be easily located and removed without the intervention of the person. Okay, the lineman need not go there and change it. Okay, automatically it will be taken care. Okay, similarly, if there is going to be any environmental factors, okay, like cyclone is going to be there, or there is going to be huge flooding is going to happen, then I can have an environmental sensor. This environmental sensor will provide data to the expert system. So the expert system will be having already knowledge present as a database. This knowledge database along with your artificial neural network will be able to have a protective system. Okay, so it may predict that this has happened. So it is an energy transmission line. So let us open the transmission like that. We have to protect the transmission line from the physical damage. Okay, caused by because of the natural problem. Okay, so all these things can be applied for your power system. Okay. So this is the basic comparison of your AI techniques. Okay, so knowledge system, this is your expert system,